R0 means resistance at 0 degrees Celsius and resistance at 200 degrees Celsius up to 100. So that is equals to 180 ohm. Okay, 180 ohm. So if this type of problem if you face in exams, okay, so how do you proceed? You have to question is that you have to design the electronic circuits. So design the electronic circuits means RTD. Actually, they're asking RTD signal conditioning circuits. Okay, they're asking the RTD signal conditioning circuits. Okay, so RTD signal conditioning circuits means that is a Wheatstone bridge. Okay, that is a Wheatstone bridge. You have to design on a Wheatstone bridge circuits. All the three arms are equals, and one arm that will be acting as a RTD. Okay, like already theory it has been covered. Okay, so that design you should proceed. And one thing is that one thing is just to note it here. Obviously, the parameter you have to calculate, but the main parameter there is no any input supply is given here. Because whenever you will be going to design any electronic circuits, obviously there is some input voltage. Okay, there is some input voltage. Okay, excitation voltage, excitation input should be there. So it has not been mentioned here. So that means first we have to identify that input voltage. Means we have to calculate here that first input voltage. Okay. So okay. So here the what are the parameters are given? The output voltage is given, that is 200 millivolt, and corresponding temperature, R0 and RT is given, that is 0 ohm and 200 degrees Celsius. Resistance value also given, that is R0 100 ohm and R200 180 ohm. Okay. So please you also solve with your notebook and show the steps also here. First, you know that the equation, what is the equation of the RTD? You know that is RT. So that is equals to what? RT equals to R0. That is equals to 1 plus alpha into T. Okay. So this is your equation. This is your equation. Okay. Alpha into T. Okay. So this is the equation, linear relationship RT equals to R0 into 1 plus alpha T. So now actually what are the values are given here? We know that the values are given. Values are given here. What is the here? What is the R0? R0 equals to 100. R0 equals to 100. Okay, and what is the value of RT? RT is equals to 180. Okay, RT equals to 180. Okay, RT equals to 180 and R0 equals to 100. Okay, so this is the resistance value. And what is the temperature? Temperature is given, that is 0 to 200 degrees Celsius. Okay, temperature corresponding to that is given, that is 0 to 200 degrees Celsius. So here we can write that is T equals to what? T equals to, that is 200. Okay, T equals to, that is 200. Okay, so now if we put the value here, so you can find out the value of the temperature coefficient. So that is alpha first. Okay, first calculate here the alpha. Okay, because if you know the value, you know the value of R0, we know the value of RT, we know the value of RT. Okay, and T is basically T is basically, that is a that is 100. This is a 200, because 0 to 200 degrees Celsius, that is a range. Okay, so T we can take here the 200 degrees Celsius. Okay, so now if we put the value, so you can first calculate the value of alpha here, the temperature coefficient. Please calculate in your notebook. Please calculate in your notebook.
4 into 10 power minus.
So yes.
4 into 10 power minus 3%.
4 into 10 to the power minus something, right?
Minus 3.
Minus 3, no? Okay,
Yes,
okay. So that means what? 4 into 10 to the power minus 3 means, that is, I think, 0.004.
Yes, sir.
0.004, right? Okay. So alpha you have got point, that is a 0.004. Okay. So that is your, temperature coefficient. Okay. So now what you have to do, you have to find the value of RT, actual RTD value. You have to calculate. Okay, because this is your suppose Houston bridge circuit. This is the Houston bridge circuit. Okay, this is the Houston bridge circuit. There's a there is a 4-arm. This is their forearm. Okay, another arm is the forearm. Okay, so now if we consider that all arm, these 3 arms, this arm and this arm and this arm, okay, these 3 arms. So these 3 arms, suppose considered to have equal resistance. Equal resistance means suppose there is the R0 value. R0 value 0 degrees Celsius, that is all the 100 ohms. So we are putting, so all the value here the 100, because you are all the equal arms. Okay, equal arms, right? So all the 100. So you have to calculate this one. You have to calculate this one, because this is the RRTD. Okay, this is the RRTD, because one arm acts as a RRTD, right? So you have to calculate this RRTD value at 200 degrees Celsius using the value of this temperature coefficient. So now how will you calculate? Because RRTD equals to RRTD, that is equals to R0. R0 means that it is 100, 100, 100. Same 1 plus what? 1 plus alpha you have got, that is 0.04 into T. Okay, so T, you know that T equals to what? T equals to, that is 200. Okay, T equals to 200. So using that equation, if we put the value of alpha here 0.04, so we can find out the value of RRTD. Okay, so that is the RRTD. Okay, so please calculate this value and put this value here. Put this value in this arm. Put this value in this arm. Okay, some ohm, you're getting some ohm value. Okay, using that equation. Okay, so this is the value of RRT. Means that 200 degrees Celsius you have find out. Okay, so now you have to design this electronic circuit. So this is actually the electronic circuits. It is the electronic circuits. Okay, so if we put some input supply here, okay, because this input voltage has not been given. This input voltage has not been given, and this input voltage has to be determined. Okay, this is the input voltage. Okay, so this is the input voltage, means the current flowing in this directions. Current flowing in these directions. Okay, so suppose this is the I1. I am considering this is the I1. Okay, this is the I1, and suppose, and this is your the I2. Okay, this is your the I2. Okay, this line is the I2. Okay, and you are getting the output. From here in these 2 ports. Okay, in these 2 ports, in these 2 channels, you are getting the output. Okay, you are getting the output. Okay, so you are getting the output here. So this output voltage actually is given. The output voltage actually is given. Okay, and now what you have to do here, first op amp, that is a the RTD signal conditioning circuits, means along this Wheatstone bridge. Okay, so you have to connect here, and this across the output, that is you have to connect one op amp. Okay, that is one op amp. Op amp you have to connect. Okay, op amp means that is it acts maybe one differential amplifier also. Acts as maybe a differential amplifier also, because there is a V1, because you are getting the 2 output voltage. One is that that is a V1, another one is that is a V2. So V0, that is equals to that is V1 minus V2. V1 minus V2. So this is the suppose V1 and this is suppose V2. So V0 equal to V1 minus V2. So across the output, op amp is required, because op amp, why it is required, is operational amplifier, because to amplify that signals. Okay, so that is the extra amplifier amplifying unit. Okay, in a second. So across the Wheatstone bridge circuits, in the conditioning element should come followed by the op amp. Okay, operational amplifier. Okay. So operational amplifier means that's for the amplifying purpose, for the processing purpose. Okay, op amp is used. So that is V0 equals to V1 minus V2. So this is the differential amplifier, right? So this is the output voltage. Fine. So now what you have to do now, because all of us have determined the value of RRTD using that equation. So you have got some value of RRTD, right? So now you have to find out the value of V1, and you have to find out the value of V2 here. Okay. You have to find out the value of V1, and you have to find out the value of V2 here. Okay. So suppose this excitation voltage, this is your excitation voltage, it is E input. Okay, that is your E input. This is your E input. This excitation voltage E input. Okay, So how will you solve it? This is basic, electrical mathematical concepts, basic mathematical concepts. So first you can find out the value of I1. Okay, so I1 means what we can write, the I1. I1 means it flows the current in this way. So total resistance, it cover the total these two resistance, that is 100 plus 100, that is what, 200 ohm. Okay, so I1, what we can write, I1 means V by R. So V by R means here the excitation voltage is E. Okay, so I1 equals to what we can write, that is E by 200. Okay, E by 200 I1 we can write E by 200.
Sir,
Okay,
but why will the current go to the second 100 ohm? Like after first 100, it will just go to the op amp, right?
yes. No,
Sir,
no,
after
no,
the
no,
first 100
no,
ohm, it
no,
will just
no, no,
go to
no.
the op amp.
Actually, see. Op-amp, actually, suppose this is the output line. Okay, so this is the I am drawing once again. Then you cannot understand. This is the first. Let me draw the Western reset. Okay, let me first draw the Western reset. Western reset. Okay, so this is your excitation input. Excitation input. The excitation input. So this is the E. This is the E. Okay, this is the E. So obviously current should be flowing in this direction. It is divided. So suppose we have considered this is the I1, and suppose and this is your I2. This is your I2. Okay, this is your I2. Okay. So now this is your output connection. Okay, here. Okay, so now through this terminal, we have connected here the operational amplifier. Have connected the operational amplifier here. Okay, we have connected the operational amplifier. So this is your output. That I mean to say. Okay, this is the output. Okay? So this is the that is a plus. This is the plus, and this is the minus. Okay, this is the plus and this is the minus. Okay, so now obviously this current we will consider this current when it is flow in this direction. Obviously it will flow in this direction. It will flow through this node. Yes or no? Yes or no? Because I1 is flowing in this direction and I2 is flowing in this direction. Understood?
Sir, you're assuming balance condition for
yes, balance conditions. Okay. So I1 is flowing in these directions. I2 is flowing in these directions. Okay. Got it? Okay. So across it, that we will be getting the output because you have connected an op amp here. Okay. So you have to find out the value of V1. Okay, and the value of V2. Okay, V1 minus V2, that is equals to V0. V1 minus V2, so that is equals to V0. Okay, so first thing that we can write here, what? We can write here I1 equals to what? I1 equals to what? I1 equals to, we know that E by 200 we can write. I1 equals to what? That is E by 200. I1 equals to E by 200. Okay, and I2 equals to what? I2 equals to you know the value of RRTD. You know the value of RRTD. So that is equals to what? E by RRTD plus जो value आया तुम लोग के पास जो value आया RRTD का. Okay, so that plus add this value. Okay, so that is your this value. Okay, so that is your E2. That is your I2. Okay, that is your I2. Okay, so now what will be the value of this V1? Okay, what will be the value of this V1 and what will be the value of this V2? Okay, we will consider now this V1. Okay, so V1, how will you calculate? V1 means we know that I1 into R1. V1 means what? That is I1 into R1. Okay, V1 means I1 into R1. So I1 this into R1 means this resistance value. So that is your V1. So that is your V1. Okay, so V1 that is equals to I1 into what? I1 into 100. Okay, I1 into 100, and V2 equals to what? V2 equals to I2 into RRTD. This is the V2. So V2 equals to I2 into RRTD. Okay, so we have calculated. V2 equals to I2 into RRTD. Okay. So now actually, now we don't know the value of, we don't find out the value of I1, I2, because you have to calculate the value of the input voltage. That's why I have written this expression. Okay. I1 equals to what? E by 200, and I2 equals to what? E by this total resistance. Okay. So now if we put V0, that is equals to V1 minus V2. Okay, V0 equal to V1 minus V2. Okay, so V0 output voltage is given. V0 output voltage is given. So that is 200 millivolt. V0 output is given. That is 200 millivolt. So 200 millivolt you can convert it to volt. Okay, so that is 0.2. Okay, so that is equals to what? V1 means what? V1 means, we know that I1 into 100. V1 means what? I1 into 100. Okay, I1 into 100. So I1 into I1 means what? I1 means what? I1 means E by 200. Okay, I1 means what? That is E by 200. So you have to just replace it, the value. Okay, to calculate the value of E. Understood? Got it? V1 minus V2. Okay, V1 means what? I1 into 100, and V2 means what? That is I2 into RRTD. So we know the value of I1 in this expression and know the value of I2 in this expression. Just replace it. Okay, just express in terms of E. You have to just express in terms of E here, V1 minus V2, because ultimately what you have to find out, the value of actually E, because supply voltage is very important. This input voltage here is the important, because you have to calculate this input voltage. Okay, whenever you will be designing electronic circuits, obviously there should be an output voltage and input voltage. In the question, input voltage has not been given. So studying that, you have to identify that input voltage, you have to find out. Okay, so if we determine the input voltage, then electronic circuit is complete. Using the RT, because we know the value of the output voltage, but we don't know the value of the input voltage. Input voltage, excitation voltage is not been given here. So you have to calculate the input voltage. So through this V1 and V2 expression, you have to replace this one. Okay, thus you have to express in the expression in terms of E. Okay, because you have to calculate the value of E. Understood?
So can you show what R4 was given as?
R4.
Yes, sir. So the one next. Yes, sir. This one.
Oh, all what I have seen, because in theoretical questions already you have studied that, because this is your RRTD. You have this resistance already you have determined, and all the arms are equal. All the arms equal means all the resistance
sir,
will carry 100 ohm. Okay, 100 ohm. Understood? So find
Yes,
out.
sir.
Yeah. So find out value of the input voltage E. Find out the value of input voltage E.